Hi, this is Mrs. Robel. This is Chapter 10, The Mole, Part 1. I have a special guest here today. This is Mr. Mole. Now, the reason why I have him is actually most people, when they think of the mole, they think of a furry rodent, and he's here today to show us that it's not the case with chemistry. So in this video, we're going to look at how is a mole used in chemistry. And please note that it's an indirect measurement, and it's a way for chemists to count the number of particles that are in a substance. We're going to use the mole and show you how it relates to everyday counting units. Then we're going to convert between moles and the number of particles. And then lastly, we're going to look at the mass of an atom and look at the mass of a mole of atoms. Okay, so as I mentioned before, chemists use the mole as a way to count substances. And they may be counting atoms, they may be counting molecules, they could also be counting what we call formula units, and I'll talk more about that later. The mole is an SI-based unit, and it's to help us measure the amount of a substance. So we need to know how much oxygen are we breathing, or how much water are we drinking, okay? Now, what is the mole? Notice that the mole is the amount of atoms, and those atoms are in 12 grams of the element carbon-12. So we're talking about an isotope of carbon. Now, here is a interesting number here, 6.02 times 10 to the 23rd. You'll get to know that very well. That is called Avogadro's number. Now, the reason why I have this picture here of paper is you could almost liken the mole to something like a ream of paper. So when you buy printer paper, they can't just give you like, I don't know, 52 pages here, 200 pages there. They want to have an exact amount so that every time they're selling the paper, they have exactly a certain number of pages. Well, same with molecules or atoms. We want to know exactly how much do we have. So we use the mole like we use a ream of paper to keep track of the pages or keep track of the atoms. Okay, so we are going back to using conversion factors, and in this type of problem, we're talking about moles and particles. So in this problem, we're looking at the number of molecules in 3.5 moles of sucrose. So we use a conversion factor, and look how we have Avogadro's number. So we have this ratio, 6.02 times 10 to the 23rd particles, and notice that it's divided by 1 mole. This is the conversion factor that we will use to figure out moles to particles. So the way you set it up is you obviously want to have your unit that you're trying to cancel, and with the conversion factor, notice that the unit you're trying to cancel, you're putting on the bottom, and you're left with the number of molecules. It's a huge number because atoms or molecules are very tiny, so we're going to get a large number as a result of it. Okay, the opposite would be particles to moles. So you're going to use the same conversion factor, but this time, notice that moles is on top and Avogadro's number is on the bottom. So here we have sucrose again, and we're putting Avogadro's number on the bottom. That way we can cancel out the units and we're left with moles of sucrose. Notice that the number is significantly smaller because there's such a large number associated with a mole. So you should get a smaller number as a result of it. Okay, mass of a mole. So we could actually determine the mass of 1 mole of copper or 1 mole of carbon. Please remember that elements, they have different sizes. They also have different masses. And if you were to compare the two, because copper is a bigger atom, its mass should be bigger. So we could also say if we have a substance, we can relate it to moles. And notice that this is one of the vocabulary words that you're going to be looking at with this chapter. So you can have the mass in grams of 1 mole of a substance, and we call this molar mass. So notice that we have this bag here. If we were to collect 1 mole of iron, notice that in that mole we have 6.02 times 10 to the 23rd atoms of iron. So the bigger the element, the bigger the amount. But Avogadro's number will stay the same for that mole of iron, or a mole of carbon, or a mole of copper. By the way, units, notice that it's grams per mole. So when you're writing out molar mass, you should have grams divided by mole. Okay, so here we have 3 moles of copper, and we notice that it has a mass of 191 grams in the lab. So notice that you take the number of moles that you are given and you multiply it by molar mass. So we take 3 moles of copper and we multiply it by 1 mole of copper. Now you might ask yourself, where do you get this 63.546 grams? That is actually from the periodic table. So every element has a molar mass that is found on the periodic table, and that's how we get this number here. Notice that moles cancel out and we're left with grams, so the answer should be in grams. Okay, this is a really nice flow chart, and I will share this with you. So here we have mass on the left, moles in the middle, and representative particles on the right. Depending on which direction we are going, if we're going from moles to mass, we're going to multiply it by the number of grams per mole, and this is something that you would get in the periodic table. If we're going from mass to moles, we're going to use the same value from the periodic table, but notice we're going to divide by the mass to get moles. And then lastly, if we're going from moles to particles, notice that Avogadro's number is on top because we want this to be a really big number. Or we could go the opposite direction where we have particles and we're trying to figure out the moles. So notice that Avogadro's number is on the bottom because we want to divide the number of particles to get moles. So in summary, a mole is a unit that is used to count particles of matter, and it's an indirect method. Please note that if you have 1 mole of a substance, you have 6.02 times 10 to the 23rd numbers of particles. Particles could be atoms, it could be molecules, it could be formula units. When we're looking at moles, if we have the isotope carbon-12, we should have exactly 12 grams of that atom in 1 mole. Please note also that on the periodic table, underneath each element is what we call molar mass, and that is grams per mole as a unit.